we're going to focus on isotopes. Isotopes are the same type of element because they have the same number of protons, but they're only different because of their masses. They have a varying number of neutrons. Isotopes of the same element are chemically similar. Neutrons are not responsible for chemical behavior. Isotopes are identified by their mass number because they also each have different masses. For example, there are 3 isotopes for hydrogen. There is the hydrogen with a mass of 1, hydrogen with a mass of 2, and hydrogen with a mass of 3. The hydrogen with a mass of 1 is the most common isotope. The mass of 2 is the second most common isotope, and the one with a mass of 3 is the third most common isotope. They're all hydrogen, so they have the same number of protons. Notice the atomic number for each is 1, 1, 1. Same atomic number, but different mass numbers, 1, 2, and 3. So most carbon exists as carbon-12. How many protons does carbon-12 have? It has 6 protons. How many neutrons? 6 neutrons, because 12 minus 6 tells us we have 6 neutrons. The number of protons and number of neutrons is equal. This type of carbon is considered stable. Some carbon exists as carbon-14, and so it would have the same number of protons, 6 protons, because it's carbon. However, the mass number is 14, not 12. So that means we have a different number of neutrons. 14 minus 6 is going to equal 8 neutrons. And so these are the same element. They just have different number of neutrons, which causes them to have different mass numbers. The number of protons and number of neutrons in this case are not equal to each other, and so this type of carbon is considered unstable or radioactive. So it's the proton-neutron ratio that determines if an isotope will be radioactive or not. Since carbon-14 has more neutrons in the middle, it's a little bit fatter. It is more likely to break apart or decay. So let's practice. An atom has 14 protons and 20 neutrons. What is the atomic number of this element? Well, the number of protons equals the atomic number, so that's going to be 14. What is the mass number for this element? Well, mass number is determined by adding protons plus neutrons. So 14 plus 20 is going to equal 34 neutrons. So what element is this? Well, we have to look at the number of protons, and then we have to look on the periodic table to determine what element this is. Element number 14 is silicon, which has the symbol Si. If I were looking at this symbol, how could I determine the number of protons and the number of neutrons? Well, this number is the atomic number. That equals number of protons. This number is the mass number. So to determine the neutrons, we'll take 238 minus 92, and that's going to equal 146 neutrons. Which of the following would be another isotope of this element? So isotopes have to have the same number of protons but different masses. So protons are identified by the atomic number. So these both have the same atomic number, but they have different masses. This one has a mass of 34. This one has a mass of 36. The mass is kind of skewed away from where they were supposed to be. Sorry about that. So these two would be considered isotopes of each other, and this would not be an isotope with these silicon atoms. Now we're going to fill in this chart. I'm going to do it on a Google slide. So we're given chlorine 37. 37 is the mass number, so I'll put that here. And the mass number is housed at the top left of the symbol. Chlorine symbol is Cl. We're going to cheat a little bit and look below. This is chlorine, and it has atomic number 17. All chlorines have the same atomic number, so this is 17 for chlorine. Or you could go look on the periodic table, find chlorine, and find its atomic number. Now that we know the atomic number is 17, we know two things, the number of protons and the number of electrons. To determine the number of neutrons, we're going to take this mass number of 37 minus the atomic number of 17, which is going to give us 20. Over here, Cl stands for chlorine, dash, and then I'm going to put the mass number, which is found here at the top, so that's going to be 35. So the mass number is 35. The atomic number is found here at the bottom left. It's 17, which tells us the number of protons and the number of electrons. And then finally, the number of neutrons is 35 minus 17, which is 18. here is carbon. C stands for carbon. So I'm going to write out carbon dash its mass number, which is at the top left of the symbol, that's 14. And the mass number is going to go here. Since the atomic number is 6 at the bottom left of the symbol, that tells us the number of protons and the number of electrons. And then finally, to get the number of neutrons, I'll subtract mass number minus atomic number, and that's going to equal 8. Okay, lastly, this is carbon 12, so the symbol for carbon is C. The mass number is the 12, and the atomic number is the same as in the previous, is going to be 6. The mass number we said is 12. And since the atomic number is 6, that tells us both the protons and the electrons. And to get the number of neutrons, I'll subtract 12 minus 6 equals 6 neutrons.